for linear speed, S for distance, and T for time.
So now let's talk about the function of S in the formula of V is equal to S over T. Now, in terms of S, we all know that S also stands for the arc length. So the formula for arc length is S is equal to theta r, where theta is angle expressed in radians and r is equal to the radius. So point in the edge of the circle travels in a circular path. So in linear speed, in this circle, the linear speed is defined as the travel distance by a certain point. So for example, you started here at this point. So we are about to measure the distance traveled until here. So that is just some example of linear speed. And time t is greater than 0. Distance s time t is equal to 0. So why did we include here s? Because in linear speed, it is distance, while in terms of s, it can be functional for the angular speed. So let's talk about the angular speed. In terms of s, since we define s here in the formula of v equals to s over this distance, now let's relate the formula used in arc length. So for solving the arc length, we are given s is equals to theta r. Where s represents arc length, theta is the angle expressed in radians, and r is equal to the radius. So what is the difference between this and this? They have no difference actually, but they have the relationship between it. So later we will find out what's the relationship of having the formula of arc length in the angular velocity. So another key points here is the point in the edge of the circle travels in a circular path. So mainly this talks about the linear speed. Now what is a linear speed in terms of illustrating it? So for example, this is the point. So if it rotates until here, so we are measuring the distance traveled by that point and how many seconds or time, or what is the time that it has took to get in that particular point. Let's talk about the linear speed in terms of angular speed. So as we all know, the formula of the linear speed is v equals to s over the time, while the angular speed rather is omega is equal to theta over t. Now, if we will give the relationship between the two formulas, we will get v is equals to rw, where v stands for the linear speed and r stands for the distance from the center of rotation or the radius. And also, omega stands for the angular velocity. Now, how can we get or how can we derive this formula? Now, let's take the formula of the linear speed. So v is equal to s over time. Now, I mentioned before that s has something to do with the arc length. So, arc length is equal to theta over r. So, if we will replace s with the arc length formula, it will now become v is equal to theta all over time. Now, if you will notice, this formula is the same with the formula of the angular speed. So basically they are the same. Now, if we will convert this into W, therefore we are at the same answer. So V is equal to WR, or V is equal to RW. And now we are at the same derivation. Now, let's talk about the angular velocity. Now, if you are confused if velocity and speed are the same, the answer is they are not. But in our incoming examples, there would be no indicated directions in terms of velocity. So, what is the difference between velocity and speed? So, just to make it short, speed is just the speed itself, while velocity is the speed with direction. So today we're just going to make it the same because our later examples would have no directions indicated. So now, angular velocity, the rate of change of angular position of a rotating body. And it is defined by the formula omega is equal to theta over t, where omega stands for the angular velocity, theta stands for the angle in terms of radians, and k is still equal to time. Now let's solve this example on linear speed. Number 1, first wheel with a radius of 15 inches has 3 revolutions per second. Convert the miles per hour. Now, we are given the formula V is equal to R omega, which is the relationship between the linear and angular velocity. Now, before we use this formula, we should convert the angular velocity first into radians per second. So, 3 revolutions per second. Now, we have here the conversion for the revolution into radians. So, 1 revolution is equivalent to 2 pi radians. So, we're just going to multiply it so that we can cancel out the rev. So, now we can make cancel of it. So, we arrive at 6 pi radians over second. Now, we will use this as our angular velocity. Then, let's make use now of the given formula, which is linear speed is equal to the radius times omega. We substitute the given value, so we have here 15 inches. And we have the angular velocity of 6 pi radians over second. So basically, we will just multiply it. So, by using the scientific calculator, we are used to solve this to scientific calculator since we have pi here. So we need to convert it into decimal. So I'm just going to enter here 15 times 6 pi. Then we arrive with 90 pi. So 90 pi is equivalent to 282.74 inches per second. Now, this is not yet the final linear velocity since we are asked to convert it into miles per hour. So what we're going to do is convert the unit and also the time. So first, we should convert the time. So we're going to convert it first into minutes. Or if you want, you can undergo hour, which is 1 hour is equal to 2,600 seconds. But first, let's solve the basics. And now we can cancel out seconds now. Then let's convert it into hours. There. So as you can see, we arrived now with hour. Now let's convert the unit of measurement now. So we multiply this. So 1/5 is equivalent to 12 inches, so we can cancel this out now. And finally, into miles. So there. Now we can calculate now the final linear velocity. Eventually, we arrived at a linear velocity of 16.06 miles per hour. So our final linear velocity is 16.06 miles per hour. Now let's solve the angular velocity problem. So number 2, given the linear speed of 100 miles per hour and a radius of 2 miles, find the angular speed in revolution per second. So since the relationship between the linear velocity and the angular velocity is v equals to r omega, so basically we're just going to divide both sides by r. So omega is now equal to v over r. So this is the formula that we're going to use now. So substitute the values, so omega is equal to the linear speed, which is 100 miles per hour, over 2 miles. So, as you can see, this is going to be reciprocal because dividing whole numbers is equal to the reciprocal of it. So this is just like this: 100 miles per hour times 1 over 2 miles. Now, as you can see, there's no unit for 1. If there is no unit for a particular reciprocal, you will put radians in it. So that if you convert it into revolution per second, we can get the exact value of it. So we're going to cancel this out. And we're going to eliminate first the time and convert it into seconds before converting the radian into the revolution. So we can now cancel out the hour and multiply again. And we can cancel the minute. And finally, let's convert radian into revolution. So as I've said before, 1 revolution is equal to 2 pi radian. So now let's calculate that using the scientific calculator. So I'm going to put all the values here and I'm going to show you the exact value. There. So as you can see, in the scientific calculator, it is multiplied times 10 raised to negative 3. So basically, we're going to move 3 places from the left to the left, rather. So this is what is indicated in the scientific calculator, and if you convert it into decimal, you can get 1. So we have 2 zeros. So the final angular velocity is 0.0021. Now, let's solve the last problem. So in order to determine the linear velocity of the point, we're taking an angular velocity of 12 pi radians per second at a distance of 8 cm from the center of the rotating object and run to the nearest test. Now, let's make this again the given formula V is equal to RW. Now, as you can see, it's already given in the problem. So our angular velocity is 12 pi radians per second, and our radius is 8 centimeters. So just simply substitute it in the problem. So we have 8 centimeters. So eventually we can ignore the radian symbol. So let's just calculate 8 times 12 pi. So let's just recycle again. And there. We have 301.59. So as a result, we have the linear velocity of we get the linear velocity 301.59 centimeters per second. So those are the formulas and those are the things that you need to memorize and be reminded of whenever solving linear and angular velocity. And I hope you learned something today, and thank you for viewing this video. Thank you.